and geometric. You studied those in Algebra 2 and in Pre-Cal, maybe even touched on them in geometry. So I think it was an eye-opener to me in Cal 2 that I needed to know something else. I knew that every series wasn't arithmetic or geometric because I knew about the Fibonacci series, which I'm sure you're familiar with and have heard and embedded in nature and all of that. Can anybody pipe in and tell me how I'm getting from one term to the next here? In geometric, but there's so many more super interesting series out there. I don't know if polynomial it like kind of bumped around and went like that, but hopefully you remember the day that if I wrote more of it, it fit on it, or what this word convergence that you see we're already using, it converged on it even more. So there's even series that I can do to model transcendental functions. Transcendental functions are ones like that are non-polynomial, like sine x, ln x, e to the x, and so on. All right, so I'm going to try to go to another slide now, and this is where it kind of messes up. All right, so can somebody jump in and tell me if you can see that red?
Yeah.
Okay, great.
It's like kind of hard to see though.
Yeah, that's great. I just want to see if you can see me writing. So is this better?
Okay.
Is that better? Or you mean just it's hard to see, period, or the red was hard to see?
Color.
Is the black
I don't
better?
know. Maybe just me.
No, that's fine. Is the black better?
Yeah. Yeah.
Okay. All right. So probably white would be good, but I don't know if I have that choice. So I'm just going to, what about, that's probably, is that black or yellow?
Yellow.
Okay.
Yellow.
All right. Oh, there's white. Okay. I'm learning as I go. All right. So the geometric series, and by the way, there's a difference in the word series and sequence, and people, even inside math, much less outside math, tend to use those words interchangeably. A sequence would be a list of numbers. It's just a list of numbers. This one would diverge right here. And when you're talking about a sequence converging, which we hardly ever do, if we're talking about a sequence converging, we're saying that the nth term, the limit of the nth term would go to 0. It means the last getting smaller as I go, and the limit of the nth term is 0. All right, big deal here. So let me write this up here. I'm not talking about geometric right now. 1, 1/2, 1/3, 1/4, 1/5, blah, blah, blah. All right, so I'm going to go back to where I can see your faces for a minute for myself. Does anybody know what that series is? 1, 1/2, 1/3, 1/4, 1/5? It has a name. I know. I don't know if I've mentioned it to you yet. Oh, it may have come up with P series.
Is this the harmonic series?
Yeah, who's that?
Sophia.
Great, yes. Thanks, Sophia. It's the harmonic series. Awesome. All right, now, Sophia and everybody else, actually, this is a harmonic sequence because it's a list of numbers. Let me ask you a question. Can y'all still see my screen? Like, can you see
like
my screen right now?
The grid.
It goes to grid when I do that?
Yeah.
Okay, so I've got to be on it for it to be big. Okay, so I'm back on my thing. All right, now is it bigger? Harmonic series diverges. Okay, by the P series test. They can be proven actually, 1 over n to the p. It's 1 over n to the first. So if I have the sum of 1 over n to the p as n goes from 1 to infinity, and if p, just common sense reasoning, I guess is what I'm saying. If you have 1 over n cubed, this is going to converge because like the graph is going to get really, really close to 0, and the numbers will start to be so small that they're not adding to the sum. Whereas 1 over n, or 1 over square root of n, which is p, is 1/2. It's higher, it's taller away from the axis if you're looking at the graph. But you can just memorize this. It converges if p is greater than 1. All right, so this is the harmonic series. Any questions about what I've said so far? Okay, so let's see where I want you to be right now. And by the way, we won't go, well, it's already 11:12, I guess, with introduction. I'll try to wrap it up really quickly and give you a little bit of homework so you're not sitting here doing this the whole time. I know it's just different. Okay, can you see my screen? So somebody give me a thumbs up. You can see the new screen. All right, thank you. I'm about to start writing. So just scream out if you don't see the writing, because it is kind of cumbersome sometimes. Okay, so what you're supposed to know right now is there's something called an nth term test. Actually, so you really need to watch the AP exam and see what word they use. If they all of a sudden start talking about a sequence converging, they just mean you can see it's getting closer and closer to 1. That's called converging. The nth term test, a bunch of y'all did an awesome job of writing in your comments that you saw that the nth term test can only prove divergence. It cannot prove convergence, but it means you better at least look at it, okay? So if I have the series, the sum of 1 over n as n goes from 1 to infinity. First of all, it does pass the nth term test. You should nth term, the limit is going to 0, not bigger. You're trying to add numbers that are not virtually 0. So first of all, check the nth term test. It passes that. But then I don't remember in the video if I proved that this one would actually diverge. You could. And then if you take the sum of 20 terms, it just keeps changing on you. It's not converging. Whereas if something converges, when you take a partial sum, yeah, the 10th sum of 10 might be bigger, but at some point it settles in to a certain number, like 3.99999. It's heading toward 4 for sure. It's not getting bigger and bigger and bigger. And so you should know the nth term test. All right, the other one that you should know, going to another slide. Let me make sure my slides match up. Or hear me. And so you should know the nth term test. All right, then you should know the p-series test. So if I have a sum like this, 1 over n squared, as n goes from 3 to infinity. I kind of threw that 3 in there to talk about. It doesn't always have to start at 1, so really keep an eye on what you've got there. But if I write out the terms, I get 1/9, 1/16, and 1 over 25. And that's the sum of 3, so I'll go dot, dot, dot. All right, now another thing I want to say that's really, really important right now is whenever you're working with series, which is what we're wrapping up with in the next few classes, whenever you're working with series, please always write out a few terms. You'll see that as I go. Always, always write out a few terms, because you'll get a feeling for what's going on. You might notice things you didn't notice before. Plus, when you're finding the sum, a lot of times you need to know what a few of the terms are, which I'll talk about later. All right, so this is a p-series. So say I was working this problem and they're asking me if this one converges. Okay, Well, first of all, I would check the nth term test. I can see that it's bottom heavy, and so the limit is definitely going to 0. So it passes the nth term test, which means it's worth looking at. And then it passes the p-series test. So then I'm done. That's all I have to say, because the p is greater than 1. And so it converges. Okay, so that's where we should be right now. And now I'm going to move on to the next series. Oh, you don't have to know the integral test. Most of y'all got that integral test. I used it to prove some other things. I might still use it, but we're going to go for it as if you're not going to be tested. You might still see it crop up in homework, but I'll try to avoid it some in homeworks and assigning you things on the exam. All right, now another slide. All right, so let's look at this example. I want to do the sum as n goes from 1 to infinity. This is an example in your book. I'm in chapter 9, section 5. And it's got -1 to the n plus 1 times 1 over n. All right, in our question here, does it converge or diverge? So I'm going to start by filling in at wherever they tell me. I'm starting at 1. If I fill in 1, I get -1 to the second times 1 over 1. And then I get -1 to the third times 1 over 2. And then I get -1 to the, I'm filling in 1, I got squared. I'm filling in 2, I got cubed. I'm filling in 3, so it's -1 to the fourth, and 1 over 3. So be careful, just go slowly. This gives me a +1. I don't know why I put 1 over 1. This gives me a -1/2 and a +1/3 and a -1/4 and a +1/5 if you kept writing it out, if you were writing more and more and more. Be careful, things don't always alternate, so this is called an alternating series. So new topic today. This is called an alternating series. And we can tell pretty easily if it converges. The alternating series converges if these 3 conditions are met. First of all, if it's alternating. And so let me pause and talk about that. I've seen series go 1 minus 1/2 plus 1/3 minus 1/4 minus 1/5 minus 1/7 plus 1/8. It's odd for it to do that. It's unusual, but make sure that you verified in your own mind that it is indeed going to go back and forth from positive to negative, positive to negative. This one's pretty easy to tell. In the event that we hit on one day that's not alternating, I'll point it out to you so that you can see what I mean by that. But first of all, verify it's alternating. Second of all, see if it passes the nth term test. And then third, if one term is less than or equal to the term before it, then it converges. So in other words, this tells me it's getting smaller. This is kind of the time I hate not being in class where I can see your faces if they look clear or not. But if you understand what I'm saying. But this means I'm going to find the term after this term, and it better be getting smaller. Like for 1/2, 1/3, 1/4, 1/5. This, what we just found, is the alternating harmonic series. All right, so the harmonic series is 1, 1/2, 1/3, 1/4, 1/5, your exponent here. So 1, I'm going to nth term test. In fact, it doesn't matter what order you look at these 3 things in. You want to obviously verify that before you start a problem anyway. Okay? Somewhere. All right, anyway, we'll go back to cows. Okay, so the p-series test where p is greater than 1 will converge. The nth term is the premier test. By itself, it cannot prove convergence, but you should look at it because it can prove divergence, which means you don't even have to work the problem, like it's game over. And geometric. Geometric, it's most likely geometric or they wouldn't be asking you. The formula for the sum of a geometric series is a sub 1 over 1 minus r. And I'll talk about that some more also. It's hard to find the sums of some of these series without set formulas. And so if it's geometric, it has like a set formula. All right, so we should know P series, nth term, geometric, and now it's less than or equal to. And if it passes, oh, that's the nth term test. And if it's alternating, verify first of all that it's alternating. Okay, so now, okay, it does pass the nth term test, the limit, 3/4. This is 1/2. Isn't this less than 1/2 for sure? The next one would be 6 over, and that's where this is important right here. 3/4 is less than 1. 1/2 is less than that. 5 over 16 is less than 1/2, and so on. And so it meets all three criteria, and so this one does converge. Let's see. Let's look at a different one here. And then I'll probably let you go. Let me catch up with what slide I'm on. Okay. Another. So anyway, let's write out. Okay, sorry. You check and see if it's alternating. You check and see if it passes the. So you'll catch me sometime working on a problem that I haven't even checked the nth term on. So let's call each other out on that as we can. I'm going to write it down just for argument's sake. If I fill in 1, I get a positive 1. And if I fill in 3, I get 4 over 3. Oh, okay. All right. So it is alternating. It is getting smaller as I go. Well, it's not really getting smaller, is it? Hang on. This is 1.5. This is 1 1/3. Yeah, so it is up. There's no way I'm going to get a sum because that last term is still really big. It's still changing, clicking the sum over to other things.